Today we're going to be talking about solving quadratic equations by graphs and factoring. So it says consider the equation x squared minus 8x plus 15 equals 0. It says we're going to show numerically that x equals 5 is a solution. So what you do in that instance, guys, is you take x equals 5. So wherever you see an x, you're going to plug in at 5. So what I have is 5 squared minus 8 times 5 plus 15. 5 squared is 25. 8 times 5 is 40. And when I combine my like terms, I end up with 0. Okay, so let's look at another way to find a few more solutions. So it says there is another solution to the equation. Use the table to find the second answer. So we're going to plug in 1 through 6 in the exact same equation to find out whether or not it's a solution. Now remember, in order for it to be a solution, I want my answer to be 0. Okay, so when I plug in 1, I get 8. When I plug in 2, I get 3. When I plug in 3, I get 0, which is why my 3 is a solution. When I plug in 4, I get negative 1. When I plug in 5, I get 0, which is just like we solved over here. Okay, and when I plugged in 6, I got 3. So remember, when I plug in my choices, if my answer becomes 0, then it is a solution to my equation. Okay, so let's look at the next piece. It says, using the table above, we're going to plot the points x and y to sketch the graph of y equals x squared minus 8x plus 15. So I want you to use those points, and to the right at that graph below, I want y'all to plot those points. So it says, which 2 points represent the solutions to the original equation, and write down their coordinates. So remember, we said the solution was going to be 3, 0 and 5, 0. So where are both of these points located? What do y'all notice? You should notice that they were both on the x-axis. So those are my x-intercepts. So you should notice that the word 0, the word solution, the word roots, and x-intercept all mean the same thing, guys. Okay, so let's scroll down a little bit further. It says, here we found both solutions to a quadratic equation using a method like trial and error. However, there are other more efficient methods for solving such a quadratic equation. So we're going to work a few of these in parts. Part 1 is going to be how I can find it in graphs and tables, which is what we've been working with. Part 2 is factoring, so your SPT, which again you've been working with. And 3 is going to be the quadratic formula, which we'll get to a little bit later. In these cases, we use the following terms to describe the solution to quadratic equations. So if I had x squared minus 6x plus 8 equals 0, it says we were dealing with a general equation like this one with x's but no y's, then the answers are called solutions or roots. Here we could say the solution to x squared minus 6x plus 4 equals 0 is going to be x equals 2 and x equals 4. Okay, now the other type that I'm going to use is when we're dealing with functions, so specifically graphs, such as y equals x squared minus 6x plus 8, then the answers are called zeros or x-intercepts because we're specifically trying to find where they cross the x-axis. Here we could say the zeros of the function y equals x squared minus 6x plus 8 occur at x equals 2 and x equals 4. So if you notice, that's where those 2 points cross the x-axis at 2 and 4. Okay, so I want you to flip the page. Okay, so for part 1 for graphs and tables, it says we're going to use a graphing calculator to complete the chart. Now if y'all look, it says it wants me to change my window. So if I go to my graphing calculator and I hit window, okay, it's going to pop up. So if you notice for x minimum, it says I want negative 9.4. And for x maximum, I want 9.4. For my y minimum, I want negative 12. And for my y max, I want a positive 12. Okay, make sure that you change the window if it asks you to do so. Okay, so let's look at problem number 1. In my example, it says I have the factored equation, which is y equals x minus 2, parenthesis x plus 2. And it wants me to do the expanded equation. So all I'm asking you to do is FOIL. So when I FOIL and I combine like terms, I get y equals x squared minus 4. You're going to sketch the graph. And the way I know what my zeros are, remember, it's the same thing as my x-intercepts. So if you notice on this graph, I cross the x-axis at both negative 2 and positive 2. And the way I can check it is if I go to my table, and wherever I see a 0 for my y values, those are my solutions. Okay, so let's work problems 1 through 6. Okay, looking at problem 1, I have y equals parenthesis x minus 4 and x plus 1. So in my calculator, in y equals, I want you to type in parenthesis x minus 4 and parenthesis x plus 1. Okay, and we're going to go to the table. Now, based on the table, if y'all look over here, what are my zeros? So I'm looking for where y is 0. The first one I see is a positive 4. If I scroll up a little bit more, I also see that it's negative 1. So those are going to be my two values on where I cross the x-axis. Now remember I said for the expanded equation we were going to FOIL. So remember my first terms, my outer terms, my inner terms, and my last terms. And when I combine like terms, I should get y equals x squared minus 3x minus 4. Now you could plug either equation into y equals, whether it's the expanded equation or the factored equation. Okay, and when I sketch my graph, I should notice at a negative 1 and a positive 4, my graph crosses the x-axis. So my zeros for the function is x equals negative 1 and x equals positive 4. So let's try number 2. If I were to FOIL number 2, I'd have x plus 3, x plus 6. And when I FOIL, I should have x squared plus 3x plus 3x plus 18. And when I combine my like terms, I end up with y equals x squared plus 9x plus 18. Okay, so, oh, excuse me, I made a mistake. This should be 6x, not 3x. Okay, that's where I get the 9x from. So when I graph it, I should notice that my graph crosses at both a negative 6 and a negative 3. So again, those are my zeros for the function. And the way I could check is going to my table. So when I go to y equals, I can plug in either the factored equation or the expanded equation. So let's do the expanded one this time. I have x squared plus 9x plus 18. When I go to my table, I'm looking for where y is going to be 0. So if y'all notice, at negative 3 I have a 0 and at negative 6. So again, those are going to be my two solutions to this equation. So using that same information, I want you guys to work problems 3 and 4 and 5. So y'all are going to work 3, 4, and 5. Now let's talk about 6. Problem 6 says I have y equals x squared plus 4. So if I plug this into my calculator, I go to y equals, I have x squared plus 4. And I go to my table. Again, I'm looking for where y is 0. Now look what happens. I go from 8 to 5 to 4, and I go back up to 5. So here, if I go to my graph, guys, do I see anywhere where that graph crosses the x-axis? No. So if there is nowhere for that graph to cross the x-axis, then I know I have no solution. Okay? So there is no x-intercept on problem number 6. All right, so y'all flip the page. All right, question 7 says, how is each factored equation related to the zeros of its related function? So here, y'all should have noticed that the factors have numbers that are the opposites of my zeros. Remember when we set them equal to 0 and we solved? It ended up being the opposite answer. Okay, so if n is a 0 of the function, then x minus n is a factor. All right, let's look at number 8. Number 8 says equation number 3 used the same factor twice, y equals x minus 5 and x minus 5. How does this affect the graph of its related function? What you should have noticed is that there's only going to be one x-intercept. It's going to be at a positive 5. It says the graph touches but does not cross the x-axis at this point. Remember, I told you when we have a quadratic, we may have two x-intercepts or just one, or we might not have any. So look at number 9. Number 9 says equation number 4 used the negative coefficient in front of its factors, y equals negative 2, x minus 2.5, and x plus 2. How does this affect the graph? Guys, remember the negative. If a is negative, what happens to my graph? You should have said if the negative number made the graph point down instead of up, so it reflected. The negative coefficient reflected the graph over the x-axis. Okay, so let's look a little bit further down. Okay, think about it. The fundamental theorem of algebra states that the polynomial equation of a degree n has precisely n complex roots. So what's the degree of a quadratic equation? Remember, a degree is the highest exponent that we have in the equation. So you should have said 2. So if my degree is 2, how many complex roots should I have? The answer should also be 2. So guys, if I have a degree of 2, then I'm going to have 2 complex roots. Okay, so below it says, study the graphs of the quadratic functions below. Explain how they are related equations can have 2 complex roots. Okay, so what I want y'all to do is copy all of this information down. I'm going to go over it quickly. For my first graph, you should notice that I have it crossing the x-axis twice. So here there are 2 real roots. The 2 solutions are where it crosses the x-axis and can be rational or irrational. If I look at my second example, here it only touches the x-axis. So here I have 1 root. I have a double root, just like we saw up in problem number 3. Okay, the same solution are equal to the same number. That's why it's called a double root. And then my last one, if you notice, it does not touch the x-axis at all. So here I have no real solutions, and solutions cannot be real numbers because it does not cross the axis. These solutions involve imaginary numbers but are still considered complex, and we will actually get to imaginary numbers next week. So copy this down, and I want you to flip the page. I'm going to work some sample problems. Okay, looking at sample problems, it says complete the tables to determine the zeros of each quadratic function. If I go to my calculator in part A, it says I've got x squared minus 2x minus 3. So go to y equals, and you type in x squared minus 2x minus 3. And we're going to fill out the table. So go to second graph. It says I want to go from -2 to +4. So I'm going to fill out my table. I have 5, 0, -3, -4, -3, 0, and 5. So when it asks me to find my zeros, I'm looking for where y is 0. So my 2 points where y is 0 is at -1 and at +3. So my zeros are x equals -1 and +3. Okay, so you do the exact same thing for part B. So let's look at the next sample. For C, D, and E, it says use a calculator to sketch the graph of each of the functions and then tell whether the x-intercepts occur. So once you graph these equations, so let's look at C. When I go to y equals, I'm going to type in x squared minus 4x minus 5. And when I hit graph, if I notice, I should see that it crosses the x-axis twice. I can go to my table to find out where y is 0. So when I go to the table, I have a value where y is 0 at -1. Now if you notice, it crosses the x-axis more than once. Okay, so I had it at -1, and then I also have it at +5. So those are my 2 roots, x equals -1 and x equals 5. So do the same thing on D and E. Now let's look at F. It says write down the zeros of the quadratic function graphed here. We're going to work backwards and use the zeros to write the 2 factors, multiply the factors, and find the expanded equation. So let's look at that example. Okay, so in order for me to find my zeros, I'm talking about where they cross the x-axis. So if I look, I cross at a +2 and I cross at a -3. So that's where I got these zeros from. Now remember, when we go from zeros back to factors, we're going to change our signs. Because remember, they're the opposite. So here I really have an x plus 3 and an x minus 2. And in order for me to get the function, I'm going to FOIL. So when I FOIL, I have x squared minus 2x plus 3x minus 6. And when I combine my like terms, I get this function. Okay, so y'all flip the page. Part 2 says I'm going to follow these steps to solve the equation by factoring. We're going to set the equation equal to 0, factor, and set each factor equal to 0 and solve. And we'll check the solution by graphing. So let's look at sample problem A. Sample problem A says x squared minus x is equal to 6. So let's work this problem out. In order for my equation to work, I have to have everything equal to 0. So I need to subtract 6 from both sides and have it equal to 0. Once I have it equal to 0, I'm going to do SPT. So when I have SPT, guys, I have a -1 for my B term, and I have -6 for my P term. So I need to find 2 numbers that will multiply to give me -6, and that will add to give me -1. When I rewrite my equation using those 2 terms, then I'm going to group, and then I'm going to factor. So I factor out an x here, and I factor out a 2 here. So my 2 terms become x minus 3 and x plus 2. Now what it tells me to do is set it equal